Hello friends, welcome to our technical tutorial by Team SMS. In this tutorial, I will demonstrate how to use ImageJ software to analyze any distance or area by thresholding or manually. ImageJ is an open source image processing program which is highly extensible, and with its thousands of plugins, it can perform a wide variety of tasks, and that's why it is a very useful tool for the scientific community. It is a Java-based program that is developed at National Institute of Health. Before starting the demonstration, one thing to mention here is that the first software that is opened here is the basic image that is downloaded from National Institute of Health website, which contains plugins that is sufficient to do basic analysis of any image. But if you want to go to sophisticated one, or you want to get more plugins, then you can choose the Fiji ImageJ. That is also a version of ImageJ, and it is also a open source software which contains lot of plugins comparing to the basic ImageJ. In this case, I will be demonstrating the basic analysis like distance between particles and area, and that's why the basic software is preferred one because it is lighter to use. Let's use the basic one only. This is the image that is located in my desktop I want to analyze. Let's open it. You can simply drag the image to the software, or you can go to file and then open it by selecting from where it is located. Here the image comes. It is an image of nickel particles in silica matrix, where the white particles are representing as nickel particle. If you observe carefully, you will see it is written RGB at the top of the image. Before doing any analysis, we need to convert it into 8-bit mode. Go to image, type, and then click on 8-bit. Now it is converted to 8-bit image. But before going to analysis, the software does not know about the scale of the before going to the analysis, the system does not know about the scale of the image. That's why the image need to be calibrated, or the scale should be set. How to set the scale? Select the magnifying glass option here and click on the scale bar. Left click will zoom it in, and right click zoom it out. Zoom it in till it is sufficient, and then select the straight line. Draw a straight line over the scale bar. When you will try to draw a scale bar, you will observe that it would be very difficult to draw a perfect straight line. Hence, to draw it as a perfect one, you can press the Shift key in the keyboard and then draw it. You will find that now it is moving in 45-degree angle, irrespective of the cursor or mouse location, pointer location. Once the straight line is drawn, go to Analyze and then Set Scale. The dialog box appears. It's showing the pixel 101.25, that is the selected one. Known distance, it is showing as 0, but actually it is 300 nanometer. Let's write it as 300 and unit of length as nanometer. Now our image is calibrated and ready for any analysis. First, I will show how to measure the intervertical distance. Let's zoom out little bit by right clicking and then select the straight line. Draw straight line in between the centers of two particles and then click on Analyze and then Measure. Dialog box with result appears showing the length as 160 nanometer. Here you see. Then we will click on Edit, click on Fill. If you observe, one straight line with gray color is appeared here. We need to do it multiple times to get an average of the intervertical distance. Let's do it another times. Once we have done it, the first reading is already came. For the next reading, we can use the shortcut key to save our time, like Ctrl M to measure. You see the second line appears with the length value 161 and Ctrl F to fill it. Why we are filling it? Because when we will be doing it for multiple times to get an average value of the length, there will be a chance that we will be taking a particular distance, or we will be selecting two specific particles twice. We don't want to select any particular distance twice, and that's why we are filling it to make it marked. Let's do it for some more times. Draw straight line, Ctrl M and Ctrl F. Third line appears. Do it first for another one. Ctrl M, Ctrl F. Do it another one. Ctrl M, Ctrl F. Once you will feel that you have taken sufficient data, either you can click on result and then click on summarize. You will get the mean standard deviation value. Here 138 is the mean value, or standard deviation is 43, or else you can do is that by simply saving as Excel file. You can see test1 Excel file appears here, where the length value is showing. This value you can utilize to measure the mean or average or standard deviation. Thus we can measure any distance using ImageJ. Now I will show how to measure any area. Let's open the image once again. We need to convert it to 8-bit image. It is converted. Let's zoom it little bit and then draw a straight line over the scale bar by pressing Shift key. Then go to Analyze, Set Scale. Known distance is 300 nanometer. Now it is calibrated. We can analyze area. So there is two methods by which we can measure the area. One is using thresholding and another is manually. First I will describe the thresholding. Before we start the thresholding, we need to select the specific area of this image that we want to analyze. To select it, click on rectangular tab here and then select the area that you want to analyze. Why we are doing this is because all the area of the image is not perfect. Like here you see it is written B and brackets 300 nanometer. As it is a software, it will consider these values also when it will calculate the area. That's why the particular area need to be selected. Once it is selected, go to image and then duplicate it. Click OK. The selected area comes here separately. Now we will do thresholding. Go to image, then adjust and then threshold. Select red one here and then if you observe, when I am scrolling the bar, the red color is coming more and more. The red color is representing the selected area. I want to select the particles that I want to measure the area. That's why the white particles need to be covered wholly by the red mark. Let's scroll it till all the particles are covered by red mark and then apply it. You see here it is converted into a specific image where the background is eliminated and only particles are visible. Now close it and now go to analyze and then analyze particle. Here one important thing to mention is that you want to include these particles that is located at the edges or not. That depends on you. If you want to exclude those particles, click on this box, else leave it. Click this box also to display results, clear results and add to manager. Another thing is that size, circularity and show. Here a lot of options are available. We can do nothing. Outlines, there are outlines. We will select only outlines here. Circularity actually a range. It is showing the type of the circle. 1 means full circle and 0 means it's not a circle at all. I want in this case to select all the images. So the range should be 0 to 1. Let it be like what? Here it is showing the size value is also like a range. It can be started from 0 to infinite. So let's try by using 0 to infinite. Click on OK. You will see that it selected 84 particles here. And some particles are excluded which are located at the boundary. Let's do one more time to make it clear. Go to analyze particle. This time I will put it as 200 to infinite. You will see that lot of particles inside also is excluded. That is happening due to the size that we have taken as 2000, because it is setting a limit above which only it is selecting the particles. So it's depend on you which particles you want to select. In this case, this selection is looking good, so or we can decrease it little bit more so that we can get some more particles. Go to analyze particles and then I can change it to 1000. Click OK. Here it is showing some reasonable one with having 65 particles. The area is written here. You can directly get the mean and standard deviation value by clicking on the result and then summarize. Mean value is this one, 12851 nanometer squared, standard deviation 1217 nanometer. You can also save it as Excel file. You see test2 files appears here. Inside the file, all the area value is given of all 65 particles. You can select these values and draw a histogram also. You can get the mean value using the Excel functions, or you can calculate the standard deviation. You can calculate radius and diameter of the particles also, and you can get the histogram of diameter or radius of the particles also. You can draw the histogram of the area using origin. Paste the values in the origin and then go to plot and then statistic histogram. You will get a nice histogram of the values with the frequency value in the y-axis and particle area in the x-axis. That you can do using origin or using Excel. Till now I have explained how to use thresholding to measure area of the particles. If you look carefully, then you will observe that in this case, the example I have taken where the contrast is very well clear. Contrast in the sense the particle boundary or the grain boundary is very well distinguished, and therefore thresholding is easier. But sometimes it happens that this boundary is not clearly visible, and in that case we need to do it manually. How to do it manually, that I will show now. Is first select the portion that you want to measure, then duplicate it. This is the portion you selected. Now zoom it in and then select the freehand selection. Like we have selected straight line earlier case, we will select freehand selection this time. Let's draw around the particle an area and then click on the analyze tab and measure. It's showing with 5117 nanometer square area of this particle. Go to edit and then fill it so that the chance to select it another time will be eliminated when we will be doing it for multiple times to get the average value of multiple grains. Let's do it another time. Now once it is done, the first data is appeared here. Now you can use the shortcut key Ctrl M. You see the value comes here, and Ctrl F to fill the selected particle. Do it for another time. Ctrl M and then Ctrl F. Ctrl M and Ctrl F. Do it for multiple times, like 50 or 60 times. That seems to be good one to take an average of the particles, and it's depend on the distribution of the particles also. If the distribution of the particles is not that much scattered, then it will not be required to take a lot of data. But if the distribution is scattered very much, then it will be required to take a lot of values, like 100, 200 also need to be taken. And obviously it will be time consuming process. So I have demonstrated both the thresholding and manually process to measure the area. If you observe the tabs here under the image and the process, there are a lot of options like smooth, sharpen, noise, add noise, binary, FFT, inverse FFT, bandpass filters. Lot of filters are available. The purpose of this function is to convert any image that is not of good contrast to change it into a threshold level image. In our coming tutorial, I will be demonstrating these functions, and I will show how to convert any image that is initially is not possible to threshold, but after using this function we can threshold it, and obviously it will be time saving to use the threshold function rather than using it manually, because the thresholding is automatically taking care of all the particles one at a time. Thank you for watching our tutorial. Like, comment and share, and subscribe our channel for our upcoming tutorials. Thank you.